Okay, everybody, welcome to part 3 of chapter 9. In this section, we're going to compare variation in two samples. So the last time we compared the statistics regarding the entire sample, and in this section, we're just going to be comparing the variation in the samples. We're going to be using information that comes with the textbook off of the CD. And let's go ahead and jump right into the example. We're going to be doing number 10 in section 9.5 or 9-5 in chapter 9, which is on page 522. Very similar to the problem you're going to be doing for your homework. In this case, we're going to need to access a data set from the CD, which is braking distances of cars. And so since they're labeled a little different, I'm going to go ahead and jump. There we are. And we are going to find something that there it would be, cars. Okay. And here's the data set. Now let's read the problem, and we're going to have to play with this data a little bit. And this is the first time we're going to have to do that, so I'll show you how to do it. Problem 10, braking distances of cars. A random sample of 13 four-cylinder cars is obtained, and the braking distances are measured and found to have a mean of 137.5 feet and a standard deviation of 5.8 feet. A random sample of 12 six-cylinder cars is obtained, and braking distances have a mean of 136.3 feet and a standard deviation of 9.7 feet. And this is all based on data set 16 in Appendix B. And this is, before I continue, this is very important because all of those standard deviations and means DDXL will do for us, so we don't need to pay attention to those. Now there are other ways to do this problem. You can use other methods in Excel. You could use descriptive statistics, which the book does a great job of showing you how to do. You're welcome to do it that way. You're also welcome to do all of these calculations by hand. The book also shows you that. I'm only going to show you one way, the DDXL way, but once again, you're always free to use whichever method you prefer. Okay, the remainder of the question that I haven't read yet is use 0.05 significance level to test the claim that braking distances of four-cylinder cars and braking distances of six-cylinder cars have the same standard deviation. So we're basically trying to figure out if the standard deviations are the same or different. And the reason you may want to do this is to determine which are more consistent. If the standard deviations are similar of these two, then you know that there's a lot of consistency in the braking distances. So there's a lot of reasons why you may want to use data like this. But first thing we're going to have to do is organize our data, because we need to enter into DDXL information on all of the four-cylinder cars and the six-cylinder cars, but they're all jumbled up, as you can see in this column. So what we're going to do is go to Data, and then we are going to highlight these columns, and we're going to go to Sort. And it will say Sort By. We're going to want to sort by cylinders. Smallest to largest. That'll put the fours at the top. Okay, now you see what it did? Is it put all the four-cylinder cars at the top, right above all of the six-cylinder cars. And let's remember, we're not doing any statistical analysis on the cylinders. That's just how we're organizing the data. The actual statistical analysis will be done on braking. Okay, important thing to remember. So let's go ahead and get into DDXL. So we go back to add-ins, DDXL, hypothesis tests. Slide this over so we can see what we're doing. And in this particular case, what we want to do is F-test of standard deviation. Okay, and we're going to enter in our first set of variables, which is column D, okay, because that's the braking, and we're going to go column D2, which is where the data starts for four cylinders, and it ends at 14. So D2 to D14. For the second variable, we're going to do the six-cylinder, which start at D15 and continue on down to D26. And then we hit OK. We're going to set our significance level at 0.05. In this particular case, they're asking us, the question is to test the claim that the braking distances of four-cylinder and six-cylinder have the same standard deviation. So it's not asking if one standard deviation is greater than another, which would be these two. It's asking if they're the same, which is our cue to the equal sign there. We're going to click on that and then hit compute. Okay, gives us our p-value, and it says we failed to reject the null hypothesis. Okay, which in this case, it means that there's not sufficient evidence to say that the braking distance, to reject the fact that the braking distances have the same standard deviation. Okay, there's double negative in there, so it's always a little bit tricky, but we cannot reject the null hypothesis. So we're going to say, and I'm going to read this to you right out of the back of the book where the answer is, because they say it better than I can. There's not sufficient evidence to warrant rejection of the claim that braking distances of 4-cylinder cars and braking distances of 6-cylinder cars have the same standard deviation. Okay? So that's what the data means. The p-value, you will see, matches is very close to the number in the back of the book, but some of the other numbers don't match. That's because the numbers in the back of the book were derived using a different method. But this method with DDXL is the most efficient, is probably the easiest, and it requires the least number of steps. So once again, you're welcome to use whichever method you want to solve this problem. The book takes you through several of them. This is the one I prefer for simplicity. And the problem we just did is very similar to the homework. However, for the homework, you may want to make sure, if we go back to this here, that you're probably going to want to look at these two, because you're dealing with the variation in one is greater than the variation of another. So that's just a little hint in the homework that you're going to want to look at these two rather than simply a comparison, rather saying, I should say, that for the problem we just did, we were trying to figure out if the two standard deviations are the same, which means you use the center one, and for the homework you're going to want to see if one is more, the variation is more for one than another. So that's my hint. I will be back for Chapter 10. Please contact me with any questions.